Metra is one of the largest and most complex commuter rail systems in North America, serving Cook, DuPage, Will, Lake, Kane, and McHenry counties in Northeast Illinois, operating nearly 700 trains and providing nearly 300,000 passenger trips each weekday. Following a fatal head-on train collision near Los Angeles in 2008, Congress required that Positive Train Control, or PTC, be installed on freight and commuter railroads across the United States. As a result of this congressional mandate, Metra and its freight partners are in the process of installing PTC on all 11 Metra lines. PTC is a microprocessor-based, communications-based train control system that is designed to prevent train accidents. It's a life-saving technology that can prevent derailments and train collisions, as well as increase safety for railroad workers. But PTC is a complicated system. It's not an off-the-shelf technology and must be built from the ground up. Metra expects to spend about $400 million to install PTC and $15 to $20 million per year to operate it. Why is PTC so complex and so expensive? The first answer is hardware. Each Metra locomotive and cab car must be retrofitted with onboard computers and communication systems strictly devoted to PTC. For Metra, that's 150 locomotives, 187 cab cars, and 186 Highliner cars. Then there's the wayside equipment. Hundreds of antennas, towers, and radio communications bases must be installed along Metra's 11 lines to monitor the signal system and communicate its status to the train's onboard PTC system in real time. Along the 5 lines that Metra directly operates, that's 227 communications towers and 219 wayside radios. The 6 lines operated or owned by our freight partners, the BNSF, UP, and CN, will also require similar numbers of new towers and communications equipment. Signals and switching points are also being upgraded throughout the Metra system. Finally, a centralized back-office system is needed to store and communicate PTC information to and from the trains and wayside locations. Radio frequency bandwidth is also required to handle PTC's communications requirements. Adding to the expense and complexity, each component of the PTC system must incorporate multiple levels of redundancy to ensure continued and safe operation. To carry out this mandate, Metra has had to hire dozens of electricians to install PTC on our equipment, dozens of signalmen to install PTC along the right-of-way, and create a group within Metra's engineering department to design, install, update, and maintain the overall system and back office. The second answer is software. PTC software must be customized to each railroad and its specific attributes. This requires that the specific features of every Metra line be precisely mapped in the field and then translated into the PTC software. It also requires that every train traveling through Chicago be equipped with compatible PTC equipment. To facilitate this work, Metra created a lab to develop, test, and update the software and hardware for every PTC component. The lab duplicates PTC's wayside, back office, and onboard equipment. The lab is used to test PTC system operations as they are developed and will continue to be used to test future software and hardware upgrades. The third answer is interoperability. Chicago is the most complex railroad network in the country, with 1,300 to 1,400 trains operating over multiple railroads every day. The PTC mandate requires that all PTC systems be interoperable. This means that any train operating over another railroad's tracks must be able to communicate with the back office of that railroad's PTC system, in addition to its own system. For Metra, that means our commuter trains must be able to talk to freight railroad back offices, such as BNSF, UP, and CN, and vice versa, and these communications must be seamless. Metra's Southwest service is an example of just how complex this will be in practice. A single train trip on the Southwest service line will require seamless communication with 5 different railroads in addition to Metra, as the train moves through territories or rail junctions controlled by Amtrak, Norfolk Southern, the Belt Railway of Chicago, CSX, and the Indiana Harbor Belt. PTC implementation is fully underway. Metra's next big milestone will be to have PTC installed and operating in revenue service demonstration on the Rock Island line by the end of 2018. Metra plans to have the rest of its rail lines fully operational by the end of 2020, in full compliance with federal law. While it will cost Metra $400 million to install PTC, riders are unlikely to ever notice anything different. But this state-of-the-art system will add an important layer of safety to train travel in Chicago.